let's see, I only got these 3 problems. Was I supposed to get more, or?
Check it. You probably have more emails with them.
Oh, hold on. I got lots of them underneath there. For some reason, I wasn't scrolling it. No, I got plenty of problems. You tell me where you want to start. First of all, I think we should start on number 1 because I see a mistake that you made when you were.
Yeah, but I have like a lot of the corrections already done that my mom did.
Okay. Okay.
So how about we do number 20?
All right.
And then we can go back to those after.
Okay.
Terms.
Okay. So for number 20, the way you should always start these problems is with the general equation of the vertex format. What is that?
Y equals mx plus b.
No, that's the general equation of a line, of a linear. Generally,
what's it called? The quadratic form?
No. What's the vertex format? In other words, here, let's go back a second. The way you did number 1 was to put it into vertex format, or you attempted to. Number 2 is already in vertex format. Number 3 is in vertex format. So what is the format, the general format? Y equals
a squared plus b squared equals.
No. Here, let's have a look. X minus h quantity squared plus k. Okay? That's the general format. And that's how you want to make this equation. Write the equation of the quadratic in vertex format. Well, this is the format. So what can we fill in? What do we know about the curve so far?
The vertex and the point of the curve.
Okay, we've got 4 variables here. We've got A, H, and K. Those are the 3 we're going to need to solve for, 3 variables. Okay, do we know any of them at this point?
No.
No, this is vertex format. They're giving us the vertex. The vertex is at minus 3, 4. So what's H?
4.
Negative 3. H is the x-coordinate of the vertex. What's K?
K is...
Look up on the problem. Yeah, gives you the vertex. K is 4. You with me?
Yeah, I am.
Okay. So now we can write this much. Y equals A times X minus a negative 3, which is the same as X plus 3, squared, plus K, plus 4. I know K is 4. Okay? Now, the only thing I have to solve for is A at this point. Well, they gave us a point that's on the curve. There's a point that's on the curve. Can I solve for A?
Yeah.
By doing what?
Here, let me move this thing. K, you can solve for K by, I guess you have to start by plugging those in.
Okay, tell me what to write next.
First, you have to, X would be negative 1.
Okay, start from the left and go right, all the way.
Negative 12 would be Y.
So negative 12 equals A.
Yeah, and
times what?
Y. No, -1 equals x.
Okay, so when I say plug it in, this is what I want you to do. Don't try to solve it yet. Just plug it in. In other words, take this point, that's the x coordinate, that's the y coordinate, and plug it in for x and y. And then you have one equation and there's only one variable, a, and we're going to be able to solve for that variable. Let's do it. What's the next line here?
Well, we're starting to solve it. So basically what you do is you can make it all equal to 0, so you add 12 to the other side.
Not if we're trying to solve for a. We're
So
no longer really have a quadratic. We have a linear equation now. In other words, the only variable is a, and it's to the 1 power. So if I can isolate a, I'm going to have my solution for a. So use PEMDAS, the order of operations. What's -1 plus 3?
-1 plus 3 equals 2.
And then 2 squared?
Yeah.
What's 2 squared?
4.
So we have, at this point, -12 equals 4a. I'm going to put that in front of the a, plus 4. What's next?
You subtract 4 and put it on the other side.
Finally, what's a?
-4.
Okay, now...
Here, could I write, give me a second to write this down real quickly.
Okay, I won't take it out.
Just the last part of it.
Right.
I just need to write down the last part.
Okay, we still don't have an answer yet. In other words, their answer is write the equation. We haven't done it yet, but we have solved for a. Now I got to go back and write the full equation. What is that going to be?
Basically, you're going to go up to where we started and just plug in the a also.
Correct. In other words, we're going to go to number 1. So our answer is going to be y equal -4. And now your answer always has the x and y in it. Okay? The only reason we plugged in that point was so we could solve for a. But in terms of the equation of the quadratic, this is it. And you will always have an x and a y, and this is squared, excuse me. You will always have an x and a y in your answer.
So for vertex form, the point of the curve is like
it's that they're just saying that that is a point on the curve. We don't know where.
Could you record this and send it to us, right?
I record it and I post it, and I have sent you a link that lets you see it the next morning, and
okay.
I can resend you that link if you want.
So would I be able to look at it like right after?
Not right after, because it takes my computer a while to process it, and I have a session at 6:30, so it's probably going to be tomorrow morning, unless you really want me to get it done tonight, and then I can probably post it tonight.
Okay, I'll get back to you on that.
You have a test? You have a test tomorrow?
I'm retaking this because I did really bad on it.
Let me see if I can get it posted. I might be able to get it posted by 6:30. Do you know how to get to my YouTube channel so that you can see the file?
Yeah, as long as you have like a YouTube channel I can look up, sure.
Yeah, it's YouTube Digital Math Tutor.
Okay.
And your file will have your initials, SL, along with the date, 11/21/16. That'll be your file name. And find that. It'll be the first one there if I post it tonight and you look at it at 6:30. I should be able to get it. I should be able to post or process it by 6 and get it uploaded by 6:30 before my next appointment. So yeah.
Okay.
The key on this problem is this step 1. Well, not even step 1. the key on most problems is always start here and then fill in everything that you know.
Why H and K? And like, because I don't know which
H
one.
and K
Like
is the vertex. H is the x coordinate of the vertex. K is the y coordinate of the vertex. And A, you don't know what it is at first.
So okay.
Okay?
I guess.
That's why they said write the equation in vertex format. Well, you've got to know what the general format is before you can do that.
Okay.
Okay? It's not the quadratic. In other words, I see a quadratic down here. I don't know if that was part of solving. That's probably part of solving 19, huh?
Yeah.
Okay. There are three formats for quadratics. There's the vertex format, there's the x-intercept format, and there's the standard format. And what you really need to be able to do is switch between any of them to the other two at any point in time. In other words, if I give you a quadratic that's in standard format, you want to be able to put that in vertex format by completing the square. And that's what you did on problem number 1. In other words, that's standard format. Okay? Well, what we really want to do is put that in vertex format, which you almost did. You came close. It's just you didn't complete the square quite properly. You added 4 to complete the square, but you you added 2. You should have added 4. Oh, I see. This minus 2 is minus 2 points off, not meaning you should have subtracted 2 from that. Okay. On number 1, you need to complete the square and then counterbalance it by subtracting 4 from the same side. So you end up with a 1 as k. In other words, you end up with x minus 2 squared plus 1 after you've completed the square. And now you can graph it. Once you've got it in vertex format, it's pretty easy to graph because you have a point where you can start, and that's the vertex.
So what I should have done for number 1 is just brought 5 onto the other side and completed the square.
No. Here, let's do number 1. First of all, again, start out with the vertex format. In other words, start out with the format you're trying to put it into. Okay? Well, what I have is this. Here's what I'm going to do. In order to try to put it into that format, I'm going to put parentheses around that. I'm going to complete the square by taking half of 4, which is 2, squaring it, adding 4, but I just changed the equation, so I have to subtract 4. The key when you're completing a square is to make sure you never change anything. Those two are identical. You see why?
Yeah.
I can get from the bottom row back to the row above it, and nothing has changed. This plus 4 cancels with this minus 4, and I'm left with what I started with. Well, the thing is that now I can write this as x minus 2 quantity squared plus 1. And you're always going to be able to do that. In other words, the reason you complete the square is so that you can write it as a linear term squared. And this is in that format. A is 1. But this is the equation, and this allows me to graph it really easily. All I have to do is start at the vertex and then find another point. And that's it. In other words, I'm going to start at the vertex, which is 2, 1, not 2, 5, but 2, 1. And then I just can pick any other value for x, figure out what y is, plot it, use the process of symmetry like you've done here. You did everything right here except one thing, and that was you forgot to counterbalance that plus 5 with the plus 4 you added in order to complete the square. You did it over here on the left, But notice you really don't want to take that 5 to the other side. That's not vertex format. Vertex format, you got y all on one side by itself. It stays there. So leave the k, leave the plus 5 over there, just move it over, and then whatever you have to do to complete the square, counterbalance it by doing the opposite on the same side of the equation. Always. If the number is on the other side of the equation, then do the same thing you did on the other side of the equation. But you have to counterbalance it one way or the other. In other words, you're not allowed to change the equation at all. You're just allowed to manipulate it. Okay?
Yeah, okay.
And
Makes sense.
number 2, it's in vertex format, so immediately we know our vertex is at 1, 3, which is her red line right there. And then again, she just substituted any value she wanted for x, probably 2 or 0, figured out what y was, and it allows her to finish this graph in red. All right.
So for number 1, like, I understand. Why is there a -4 though? Like, why do you subtract the 4?
Okay. Here.
Like, you just like you add it
I'm going to
because.
explain it to you exactly. Let's go back to this step right here. Remember, is all I am doing is manipulating the equation. I'm not changing the equation at any point. I'm just manipulating it.
Yeah, but where did you get that 4 from? Like the 4 that
that's
you
the
added?
process of completing the square. The way you complete the square is you take half of this coefficient, you square it, and then you add it right there. Well, I can't write in a plus 4 there. I've just changed the equation. I've added 4 to it. So if I want the equation to be exactly the same, I got to subtract 4 from the same side. Now it's the same.
Okay, I guess.
Whatever I would have written in there, I would have had to do the opposite outside the parentheses.
So it's like completing the square, but it's not like instead of moving to the other side, you just move it out of the parentheses.
Not moving it to the other side. And in fact, you won't be doing that till you get the conics. Once you get the conics, then you tend to move that number to the other side, and then completing the square is slightly different. You still complete the square, but whatever number you added to the right side of the equation, you also add to the left. Well, in this vertex format, everything's on the right. There's nothing on the left except y. Okay? So when I complete the square inside the parentheses, I've got to counterbalance it over here.
Wouldn't it be plus 4 though? Because half of 4 squared is positive 4. So then.
That's why I wrote plus 4 in there.
What about on the other side? So you subtract it from the other side?
No.
Or the outside of the parentheses?
Subtracted it from the same side.
Well, the outside of the parentheses, I mean.
Correct. In other words, this bottom line right there that I put a check mark, that's the same as the equation they gave us. And that's what we want. We want it to be exactly the same. If it's different, we've made a mistake. I'm not changing the equation. All I'm doing is writing it in a different form. And I'm trying to write it in vertex format. So notice that that right there is exactly what we started with. If I were to simplify this, that plus 4 and that minus 4 would cross off, and I'd be left with x squared minus 4x plus 5, which is what you started with.
Okay.
Okay? All right, let's...
Could we go to number 22
yeah.
and 21?
Yeah.
Because, yeah, I need to do those for corrections.
All right. I'm All right. (21) is, there's only one way to do 21. And that's to come up with 3 equations, 3 unknowns. Because we don't know the vertex. We don't know anything about it except these 3 points are on the parabola.
So couldn't we do the process I did?
Yeah, it looks like you can do it exactly that. In other words, if you write the, probably the best way to do this is to write it in standard format. That's standard format. Okay. Now, take the first point, substitute it for x and y, and what do you get?
It would be -4.
Hold on. You're getting your x's and your y's mixed up. You're going to start and go from left to right. You got to start with y.
Okay, -7 and then -4.
Give me the entire line.
And then a -4 squared plus b -4 squared plus c.
The second one's not squared.
Oh yeah, not squared, right.
Okay, if we simplify, that gives us there's one equation. Okay, what's the second equation? We're going to label that number 1.
So we're doing it the way I did it?
Uh-huh. I don't really know of another way to do it.
Okay,
I'm
so...
not sure why you lost 3 points on it. I got to go through it to figure out where your mistake is. Looks like you got the first one correct, 16a minus 4b plus c. Yeah, the first equation is correct. What's the second equation going to be?
It's going to be 3 equals a -3 squared plus -3, well, b -3 plus c.
Simplify that. Simplify that.
That would be a9 plus b9 plus c.
Let's put it into more traditional format. In other words, put the coefficient in front of the letter.
Yeah.
Like that. Okay?
All right, that sounds good.
There's our equation 2. And it looks like that's what you've got on equation 2. Now, finally, what's equation 3?
Equation 3 is, equation 3 would be -21 equals 3a.
Not going to be 3a. It's going to be a times 3 squared. That's where you made your mistake on that third equation. It is going to be plus 3b plus c, but this turns into 9a. So equation 3 becomes -21 equals 9a plus 3b plus c. So there we have our 3 equations and 3 unknowns. Now, solving 3 equations and 3 unknowns. You lost 3 points. Is that the maximum?
Probably.
She should have given you some credit. You got the first 2 equations correct. Or he, whoever your teacher is. The only thing wrong here is this coefficients of A in your third equation. It should be 9. You see why it should be 9?
Yeah, I do.
Because it's 3 squared? Okay. Now, solving 3 equations and 3 unknowns. Relatively straightforward when you have a plus C in all of them, because you can eliminate a variable.
Right.
So what you did, it looks like, what's this? Oh, you multiplied the second one by -1? Yeah. What does this say right here that I'm pointing at?
That's a 9a. Negative 9a.
Okay, which is correct. Okay. And then you added the 2 equations to come up with equation 4. And that's correct. Okay. And now to get equation 5, in other words, the process of solving 3 equations and 3 unknowns is to get rid of a variable and end up with equations 4 and 5 that only have 2 variables. And let's see, you've done that. You would have been correct in doing it this way, except you had the wrong number there. In other words, once you've made a mistake here, you can't recover from it. But yeah, this would be the right technique. And then you end up with equation 5. Notice that equation 5 has no C in it, and equation 4 has no C in it.
Yep.
Now you're down to a problem with 2 variables and 2 unknowns. And you can solve that by elimination also. So your process is really good here. And that's why I'm surprised you can get some credit. In other words, you would have gotten the exact answer if you'd have multiplied 3 times 3 right here and come up with 9.
Yeah.
One other thing I see is that you tried to multiply this equation by -1, but you didn't do it. In other words, that -21 should have turned into a +21. Then when you added the 2 equations, you would have had a 24 there. But somehow you ended up with a +21, which you added and ended up with a -18. So you've got a math error there also.
Yeah.
All right.
Yes, so
22. Not going to be in our best interest to go through 22. What kind of calculator do you have?
a graphing calculator. On the test, I forgot how to do it.
Well, this is a hard one to explain, and it depends on your calculator. What kind of calculator do you have?
I have a TI-84.
Okay. You have to make 2 lists.
I know how to do that.
Okay.
Like,
then you have to
2
go
lists.
in and you have to request a quadratic regression from those 2 lists. And it's going to give it to you probably in standard format. So it's going to give you an A, a B, and a C. And standard format is y equals ax squared plus bx plus c. So when you request a regression, first of all, there's lots of different regressions you can request. You can request a linear regression, which gives it to you in y equal mx plus b format, straight line. You can request a quadratic regression, which is going to give it to you in standard format usually. It may give you a choice. Usually it gives you in standard format, which means the only thing it gives you are an A, a B, and a C. And then you got your equation.
Yeah.
Okay. Once you have the equation, then you can answer questions A and B. In other
Do you
words,
just plug in?
yeah.
You just plug in 28.1 for x, right?
to speed things up here, I'm going to make up an answer. Let's presume that your calculator gives you this. After you put in your two lists, x variable being list 1, y variable being list 2, each list is going to have 10 entries in it. With me?
Yeah.
Then you request quadratic regression and you get an answer that looks something like this. Actually what you get is a equals 2, b equals minus 3, c equals 4, which means that's the equation of that quadratic regression.
Okay.
Now, how fast are you going when the fuel economy is 28.1? Well, the fuel economy is the y variable. So I would plug in 28.1 in for y, and that's going to give me my speed. In other words, now I can solve for x. Once you get it down to one variable and one equation, you can always solve for it. Okay? Might have to use the quadratic formula to solve for it, but that's okay. What is your fuel economy when you're going 81 miles an hour? How am I going to get that? Y is the fuel economy.
Right.
So how am I going to get that? If that's the equation of this table, how do I answer B?
You go to x equals 81.
Okay. You plug it in, you solve for y. So you'd have y equals 2 times...
You can just sort of have the graph do that for you.
Yeah, I mean, you don't have to do this by hand. You can have plus 4, excuse me. But it's not a question of how you get the answer, it's a question of how you formulate it. In other words, as long as you can get to this step, I know you can come up with the answer. The key is knowing what they're asking for. In other words, the key in A is knowing that they've given you the fuel economy, which is the y variable. The key in B is they're giving you the speed and they're asking for the fuel economy. So they're giving you the x variable. But you've got to have the general equation for that table. And your calculator is going to give you that when you request a quadratic regression.
Yeah.
All right. The reason I say that that might not have been worth our time was because you're only going to have at most one of those problems on the test, and you're going to have a lot of problems like everything above it. So let's make sure you know how to do some of these. Let's make sure you know how to do 18. I just want to check. Solve this by completing the square.
Okay, so what you do is you add the 2
Yeah,
to the
now
other
see,
side.
this is a little different. You're not completing the square to put it into vertex format. You're completing the square to solve. So you're right. You do put the 2 on the other side of the equation. And notice I'm always checking at every step, make sure I do not change the equation. Now what?
So basically what you do is you just, you get that and then you add it to both sides.
Hold on. You're missing, you totally jumped over a step. You got to complete the square inside the parentheses. How do you do that?
You factor it.
Huh? Take half of this.
Well, yeah, you take half of it, then you square it.
And add.
Which gives you 1.
Which is what?
Then you add that to, which is 1.
Okay.
And you add that to both sides.
Plus 1, yes. And now to balance it, I got to add plus 1 to the other side of the equation. If I was balancing it on the same side, I would subtract 1. But notice now that this is still exactly the same as what we started with. We have not changed anything. And now, keep going. How can I in other words, the whole point of completing the square was so I could write this as a linear term squared. What is that linear term squared going to be?
It's going to be x minus 1 squared.
And I got 3 on the other side. Now how do I go from here? Take square root of both sides. What's the next line?
Next one would be...
Next line.
Oh. It would be x minus 1 equals square root of 3.
Plus or minus?
Right, plus or minus.
Half, you will lose points for that, as you did. You notice, well, there is a plus or minus there. Okay. Hold on one second. Let's go through the complete solution. You see how I get this step? First of all, whenever you're solving an equation by taking the square root of both sides, always begin your answer with plus or minus. Always.
Yeah.
Now what's the next line? Because I'm still trying to solve for x. I haven't solved for x yet.
You just add 1 to the other, both sides.
Okay, and in this case I'm going to put the 1 in front because I want my answer to kind of look like what it would look like had I used the quadratic formula, and that's always this, remember?
Yeah.
So this is your answer. Now, I'm not sure why she has a red plus there. You must have had a minus before she drew that in there. Because if you'd have had nothing, she would not have taken off any points.
Yeah.
You could leave off the sign, but you can't have a negative sign. All right, let's do 19, because there's something quite different about 19 that you have to account for. Okay?
Okay.
I'm going to do the same first step with 19, which is to move the number to the other side of the table, or the other side of the equation. Now, there's something I have to do before I can complete the square. I cannot complete the square until this coefficient is a 1. So what do I have to do here on the left?
Complete the square?
Not yet. You can't do it until the coefficient is a 1. So how am I going to have a 1 coefficient factor a 4 out, right? What are you left with?
You have, so you can only complete the square when the x squared term
has a 1 as its coefficient, exactly. And it doesn't matter whether it's an even, that could be a 5, and I would still have to factor out a 5. They're making it easy here because 12 is divisible by 4, but it doesn't have to be. So what's left in the parentheses? Give me the next line.
it would be x, it would be x squared minus 3x.
All right. Don't go any further. Have we changed the equation at all?
No.
Okay. Always be checking. At every single step, make sure you have not changed the equation. Now complete the square inside the parentheses.
So it would be negative 1.5 times negative 1.5.
It's going to be easier if you leave it in a fraction, not a decimal.
And that would equal 2.25, or 2 1/4.
Well, when I say leave it as a fraction, that's half of the middle coefficient. When you square that, it's easy to square, 9/4. Leave it as a fraction, don't change it to a decimal. That's what I'm saying. It'll be easier. It'll be easier to handle it. Now, I just changed the whole equation. I just wrote in a plus 9/4 on the left side. How much did I add to the left side of the equation when I did that? In other words, I just wrote in that. It wasn't there before I wrote it in. Everything was identical before I wrote that in there. How much have I added to the left side of the equation?
You added 9/4.
Times 4.
Right, right.
So what did I add?
9,
I added 9.
oh yeah, that's true.
Yeah, I wrote 9/4 in there, but that's being multiplied by this 4. 4 times that is 9, so I got to add 9 to the right side. Now it's exactly the same. In other words, now if I tried getting backwards, I would get back to what I started with. I cannot overemphasize that process enough. You always want to be doing that. Okay?
Right.
Now, tell me how to write the next line. In other words, I've completed the square. So I should be able to write that as a linear term squared. What is the linear term squared going to be? Sam, you still there? Everything went silent. I think I lost the audio. Hold on. You're still there. I'm going to call you and we'll finish the audio. No, now you're offline.
Hello?
Yeah, hi, Sam. Looks like I lost you. You went offline. Ah, you back? Say something. Say something.
Hello?
I can't tell if I can hear you through my speakers. Say something again.
Hello?
No, your audio is not fully working. Can you see my screen?
Yeah?
I'll bet you can't see it fully. If I write a number at the bottom, what's that number that I just wrote?
I don't see it.
Yeah, you're looking at the last image you had of my screen before it kicked you out of GoToMeeting. You got to log back. You got to log out of GoToMeeting and log back in.
Oh, God. I think it...
Now, we only have 12 minutes.
I think it logged me out, like, of the internet.
It might have. What I'm suggesting is we might be better off just finishing this by phone.
Okay.
But you need a pencil and paper in front of you.
Gotcha.
Okay? Tell me when you got that.
I got it.
Okay. Let's finish this problem. Well, you can actually see what's on my screen here, right? We completed the square. Now, how are we going to write that? What's inside the parentheses? How are we going to write it? 4 times what?
4 times... Well,
How do you write that as a linear term squared? It's always going to be x. The sign is always going to be the same sign as the middle term. Now what is it? X minus what?
X minus...
Whatever you got when you took that and divided it by 2, that's what it is. It's 3/2.
Yeah.
Another reason to leave it as a fraction. It's easier to deal with fractions than it is decimals. It just is. And that's squared, so it's 4 times the quantity, x minus 3/2 squared. And what's on the right side?
Equals 8.
Okay. Now what's the next step?
Wouldn't it be to find the square root?
Not yet. In other words, you do want to try to isolate this, but it's still being multiplied by this 4. We got to get rid of that 4 before we can take the square root of both sides.
So you multiply it by 4?
Divide it by 4. I multiplied it by 4, it would turn into 16. We want to get rid of it. Right now, the 4 is a multiplier, so we have to divide both sides by 4. I know you can't see it, but you can write it on your paper that's in front of you. What's the next line? What's on the left side?
I guess, wouldn't it be 1/4 x?
No, the 4's cancel out. The whole reason we divided both sides by 4 was to get rid of that leading 4.
Okay, so, I see. So it's x minus 3/2 equals 2.
Squared equals 2. In other words, it's x minus 3/2 quantity squared, right?
Right.
Okay, it's got to be a linear factor squared. Now what's the next line? What's the next step?
Wouldn't it be to square root?
Okay, so give me the next line.
It would be 2 squared.
Hold on. You're not gonna expand that. You're gonna take the square root of both sides. So what's
X
the
minus 3/2 equals 2.
what are the first words out of your mouth whenever you're solving an equation by taking the square root of both sides?
Plus minus.
Plus or minus the square root of 2. In other words, I still have to take the square root of whatever number's over there. And now finally, what's the last line? X is equal to what?
X equals 3/2 plus or minus the square root of 2.
You got it. That's it. And that's as hard as you're going to get on completing the square. But notice we had to do a couple of things. We had to factor out that 4. And then we had to get rid of the 4 that we factored out by dividing both sides by 4.
Yeah.
All right. Let's see. I know you can't see my page. We've got 8 minutes. Let me find a problem, though. And let me go up here to some of these others. How are you on complex numbers?
With the imaginary numbers.
Yeah, it looks like you're pretty good on them.
Based on the test anyways.
What's that? There's some I notice here that you're losing points on that you shouldn't be. Let's do that.
Okay.
Here's 15. Minus I plus, in parentheses, 7 minus 5I minus 3 times 2 minus 3I. You with me?
Yeah.
Okay. When you are doing anything with complex numbers, if you're adding them, you add the real parts and then you add the imaginary parts. That's it. It's as easy as you can possibly imagine. Okay? Yeah. Well, first thing we have to do is distribute that 3, though. So what do I get after I distribute the 3? So now I got minus I plus 7 minus 5I. I can remove the first set of parentheses easily. By just erasing them, it doesn't change anything. Second set, not so easily. What am I subtracting?
Negative 3 parentheses 2 minus 3I.
Distribute that 3. I can't do anything with it until you get it distributed.
Negative 6 plus 9I.
Now I can erase the parentheses. Only thing is, it's not plus 9I, it's minus 9I. And you kind of have to see this by going back a step and noticing that if this, what I've written, or what you've written is not the same as what you started with. Take the start, distribute the minus 3, you get plus 9I, right?
Yeah.
But if I leave the parentheses there, that turns into minus 6 minus 9i. I don't want it to be minus 9i. I can erase the parentheses, and now I have the right answer. In other words, my second row should read minus I plus 7 minus 5i minus 6 plus 9i. Is that what yours reads?
Yeah.
No parentheses. And again, the secret to math is when you're doing a problem like this, make sure that it's identical to what you started with. Notice that when I distribute this negative 3 to that negative 3i, I get plus 9i. That's why it's a plus 9i. Now add all your reals together. What do you get?
You get 1.
Add all your imaginaries together. What do you get?
You get 3.
You get plus 3i. And you cannot omit the plus here. If you just wrote down 1 and 3i, you're going to lose points. Because this is not a plus sign to indicate that it's a plus 3. This is a plus sign indicating that this imaginary part is being added to the real part.
Yeah.
So you can't omit it. It's 1 plus 3i. Now, the only reason this is tough at all is because when you remove those parentheses, it's real easy to make a mistake, like you did. In other words, you started out with plus 9i, but that was with parentheses. It's very important to understand that the moment you remove those parentheses, you got to make sure you got the right numbers there.
Yeah.
All right, we have 4 minutes. Let me pick one more here that's pretty good. Okay, you lost points on 16. Let's do that one. This is another one that should be a gift. These imaginary numbers are gifts. There's no easier problem on this page than these imaginary number problems. Squaring means what? Means foiling it out.
That means basically multiplying it. So wouldn't it be 9?
No, not 9 plus 4. First of all, you've got to FOIL it. There's going to be 4 terms in your answer. What's the first term? 3 times 3.
3 times 3 is 9.
What's the next term?
The next term is... one second, I'm just getting my soda fixed.
Did they teach you FOIL?
Yeah, sorry, I'm just sort of fixing
Okay.
my...
Okay. Not everybody gets taught FOIL anymore. A lot of people get taught you just multiply every term by every term. Okay? Because FOIL works fine as long as it's 2 terms multiplied by 2 terms. FOIL breaks down when you multiply 2 terms times a trinomial. Doesn't work so hot. But all you have to remember is you got to multiply every term by every term. And use a certain order always, so you don't forget one of them. What's the second term?
Plus 6i.
Where are you getting plus from?
Minus 6i.
Well, it's 3 times minus 2i, right?
Yeah.
Okay, that's minus 6i. What's the next term?
Minus 6i.
Correct. And then finally, what's the last term?
Plus 4i.
Plus 4i squared.
Yeah, but then you can make that...
Well, but don't do 2 steps in one. Do it 1 step at a time. It's doing 2 steps in one that causes you your math errors. Now, let's simplify this. I got 9. The 2 middle terms always combine. What do they become?
The 2 middle terms become 0.
No, minus 6i minus another 6i.
It becomes minus 12.
Minus 12i. And then finally, I squared is equal to what?
Minus
Well, I squared is equal to minus 1. 4 times minus 1 is minus 4. So yes, it becomes a minus 4. So what's the final answer?
5 minus 12i.
Yeah. In other words, this is strictly a foiling of two terms, multiplied by two terms. There's nothing hard about this problem at all.
Yeah.
The only hard ones are ones like 17. Can you see 17 on your paper in front of you? Or?
Yeah, that one I did right, though.
You did. I noticed that. But notice that that's not division. That's a multiplication problem. It's just you have to multiply top and bottom by the conjugate of the bottom.
Yeah.
And so with complex numbers, there really is only addition, subtraction, and multiplication. There is no division. When you're dividing by a complex number, really it's kind of like dividing a fraction by a fraction. You don't do division, you do multiplication. You flip the bottom and multiply. Same thing with complex numbers. You're never doing division, you're always doing multiplication.
Right.
All right. Well, I'm sorry we had technical problems. That couldn't have helped things. But hopefully that'll help a little bit for your test. I'm not sure exactly how much of this is going to get recorded. Probably all the audio. You may lose the visual 45 minutes into the recording, but you should get all 60 minutes of the audio.
Okay.
All right, Sam? Okay, good luck on that.
Thanks.
Talk to you later. Bye-bye.